This is Mr. Gillum, and today we're going to draw scatter plots and talk about best fitting lines. Okay. Before we get started, it'd be good to know what a scatter plot is. And what it basically is a line graph without the lines. It's a graph of a set of data pairs. It's just a bunch of points on a chart. And there's also three types of correlations, things that can happen. And when I say correlation, I'm talking about the pattern of the data. Okay. In a positive correlation, y tends to increase as x increases, so it's a positively sloped correlation. The pattern gets bigger as you go from left to right. A negative correlation, it gets smaller as you go from left to right. It's negatively sloped. And if there's no correlation, that means there's no pattern and there's no way to really tell what the data is doing. So let's just describe the correlation. Describe the scatter plot. Okay. These are scatter plots. They're just a bunch of points on a graph. And what we could say about them is that is a positively sloped correlation. It's a positively sloped best fitting line. So we're going to say this is a positive correlation. This line is pretty accurate as far as many points go. As you can see, if you read the graph from left to right, the points keep increasing. Over here in the top right hand corner, as you go, the points are decreasing. Okay, it would be a negatively sloped, a negative correlation. And finally, here's an example of a no correlation. As you can see, there's no real pattern as to where the points are going. So we're going to say this is a no correlation. All right. So let's just look at a few more graphs just to get the hang of this. And as you can see, the data kind of flows in the negative direction. So we're going to call that a negative correlation. And the same way with this graph, there's many more points, but as you can see, the pattern, it gets lower and lower and lower the farther we go. We're going to call that a negative correlation. And we could even say on this one, if we look at the data, it keeps increasing, so we're going to call that a positive correlation. And finally, I noticed on this last one that there's points in all the quadrants, and there's really no pattern going on, so I'm going to say there's no correlation. Okay, so that's how you would describe a scatter plot, either positive, negative, or no correlation. Now we're going to approximate a best fitting line. So there's a few things we have to do here. We have to find our scatter plot. If it's not given to us, we need to draw it. We're going to sketch a line that goes through most of the points, one that has a pretty good accurate approximation. After we've sketched a line, we're going to actually find the equation of that line by finding 2 points on the sketch and then writing the equation of the line like we did the other day. Okay, so I'm going to go through one example here and hopefully it'll be crystal clear. So we have our data points here, x and y, and the problem is that we need them to be on the graph. So what we're going to do is we're going to have to graph these things. I'm going to make my x-axis, since it only increases by 1 each time, I'm just going to make it go up by 1s. 6, 7, 8, 9, 10, and so on. And what I'm going to do is I'm going to start plotting my points. Let's make the bottom number, we'll make it 200. And we'll go up by 50s. So that's 250, 300, 350, 400, 450, 500, 550, 600, 650, 700, 750, 800. And the reason I chose that big of an increment is because I noticed that my lowest number is at 280 and my largest number is at 548. I need to make sure I can fit all these on my data plot. Okay. So what I'm going to do is I'm going to say, okay, here's my coordinates, 0, 280, about right there. And then we'll say 1, 295, and 2, 322, and so on and so on and so on. I'm just going to plot all the points here from my data chart. 4, 425. 5,471. 6,511. And 7,548. Okay, so I've got my little scatter plot here, and it's just a bunch of data, just a bunch of points. I'm not connecting the dots because that would be a line graph then. This is a scatter plot. I need to just, first of all, approximate a line. I'm going to be very careful how I do this. I'm going to go ahead and start right about here, and I want about as many above as below the line. So I'm going to go as straight as I can here. I'm going to say there's my line that I want. And it's not perfect, but it is just an approximation. I'm going to say that's my line. That's the line I want to use. And I know it's not the straightest because I drew it on the Mimeo, but it's not bad. We're going to use this line to predict what my value is at 10. So just looking at the line I drew, let's just predict what y is when x equals 10. Let me just dot. And it looks like it's about 750. So I'm going to predict that when x is 10, y is 750. Okay. But that's not good enough. I actually want the equation of this line. So what I'm going to do is this. I'm going to say I know I have 2 points. Okay. And I know I have an intercept. I know that I wrote my intercept right at 250. So my b value, my y-intercept of this line is 250. And I also know that the coordinates, let's just use this one right here, 395 is on my graph. Actually, I'm just going to round it to 400 because it doesn't really have to be a data, it just needs to be close, okay, for my line. If I want to write the equation of a line, y equals mx plus b, and I have an intercept, and I have a point, I can do that. I can plug in all the things I need because I need to solve for my m value this time. So I'm going to plug in 400 must equal m times x, which is 3, plus 250. So I'm going to subtract 250 from both sides. 150 equals 3m, and divide by 3. M equals 50. That's my slope. So if I wanted to write the equation of a line in y equals mx plus b form, I could say y equals 50x plus 250. And this would be my equation of this line. And I'll tell you again one more time where I got all the information. My b value, my y-intercept, happens where it crosses the y-axis, which I just said that it was going to be at 250. And from there, I decided I need a point on my graph, anywhere on my line. I decided on this point. It's not exactly perfect, but I made it perfect. 3, 400. That was the point I decided to choose. Y equals mx plus b is the equation of a line. So I know I had an x and a y to plug in, as well as a b value. I can find my slope, which was missing. So that's what I did. I found my slope as 50. Now I have the equation of a line, and I can actually calculate y when x equals 10. So I'm going to find y when x equals 10. And as you can see, I got for an answer y equals 750. Exactly what my approximation was. Okay, when x is 10, y is 750.